Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are in the second module of this course, that is process management. So in this module, we're trying to understand how the operating system manages the CPU by providing this abstraction of a process, right? So within the second module, we are currently on the first topic, that is process introduction. And as you can see, we are now reaching the end of this topic. So in this topic, through a series of videos, we understood what exactly is a process, how does the operating system implement this abstraction of a process over the CPU, and we talked about several other ideas related to a process, right? So we now have a good understanding of the process, right? So now in this video I want to conclude this topic. Here I will quickly go over all the ideas that we discussed related to a process and summarize all the ideas that we discussed in this topic. So without further ado, let's get started. So let us start from the beginning. So in this topic, the first video that we saw was that what is a process, right? So in this video, we started with the basic challenge that when there are several programs in a computer system, as you can see here, the problem here is that the number of programs that are there in the computer system is way more than the number of CPUs. And in order to solve this problem, the operating system time shares the CPU among all of the different programs, right? And this is how the time sharing diagram looked like. And we also said that in order to support this time sharing, in order to properly implement this time sharing, the operating system needs to keep track of all the running programs in the computer. And from there only we developed the concept of a process. So a process is a running program, and in order to effectively time share the CPU among all the running programs, the operating system models each of these running program as a process. So in this video, we properly defined what is a process. So as you can see, it starts from the source code. Once you compile your source code, you get a program, which is basically a bundle of executable code and data, which the machine can understand. And once you run this executable file, that is this program, that is when it becomes a process. So each running program in the computer system is modeled as a process. So this was the basic idea behind the process. Then in the second video, we talked in detail about the differences between a program and a process. Often these terms can be confusing. So in the second video, we went over the differences between a program and a process. So at a very high level, the program is just that executable file which contains your instructions and data, which is sitting on the disk. And whereas the process is the running program. So a program is just a file, it's just a passive entity, whereas the process is a active entity. And then we also saw several differences between a program and a process, right? For example, that the process has a shorter lifespan, the program has a longer lifespan, right? So these are the differences like lifespan, resource usage, the utility, which we talked about in the second video. After that, we in the third video, we talked about the journey of a program to a process. That is how when the user launches a program, the operating system does certain activities, certain it undertakes certain tasks so that it can create a process out of the program, right? So this picture summarizes what we discussed in that video. So basically, we start from a program, right? This is the executable file which we get after compiling the source code. Then whenever the user conveys their intention that they want to launch the program, right, then the operating system comes into action and does certain things in order to launch the program to get a process. So the very first thing that it does is that it loads the executable file into the memory. It sets up the memory, the different regions in the memory, right? So that the code and data of the program is properly organized in this address space, right? This region in memory is called the address space. After setting up the memory, the address space, the operating system sets up the IO devices, right? For every process, it will do some basic setup related to the IO devices, like opening up the standard input, standard output devices, right? And finally, it sets up the CPU registers like program counter, stack pointer, so that the program can start running and then we can have a process. So we discussed the journey of a program to a process in brief in this video, right? So after understanding how the program becomes a process, we then in the fourth video, we talked about how does the operating system represent a process, right? So the process is an activity. When a process is running, a whole bunch of things are going on, right? So the CPU is executing instructions, the memory contains the basically the data and the instructions, right? The IO devices are used by the process to interact with the user, right? So a whole bunch of activities are going on. So there is this problem of representing a process, and we saw that the operating system, what it does is, in order to represent the process, in order to represent this activity, it collects all of the relevant pieces of information, right? These pieces of information that I just talked about. So when this activity of executing the program is going on, whatever the relevant pieces of information are associated with this activity, with the process, the operating system collects all of them into one single data structure, which is called the process control block. And this process control block is like the one stop source of truth for like getting any piece of information related to a process. For every process there is a process control block, and by using this process control block the operating system represents a process. So basically now there are several processes in the system, and for each one there is a process control block, and the operating system can use this process control block to get any piece of information related to a process. And generally this process control block is implemented using a C style structure, right? And finally the operating system uses this process control block to time share the CPU among the different processes. So this was how we can represent a process. Finally then we shifted our attention to understanding the life of a process, right? So we developed this diagram called process state diagram, which looks something like this, which depicts all of the different states that a process goes through during its lifetime. So we wanted to understand what are the different stages, what are the different states through which a process goes through during its lifetime, right? So we saw several states, like whenever a process is created, it is in the new state, then it goes to ready state where it waits for the CPU. Finally, when the CPU is assigned, it goes into running state, and it can terminate, or it can now go back either to block state, or it can go to ready state. So we talked about these different states in detail in that video and developed an understanding of how does the life of a process look like, right? So this was about the process state diagram. Then in the next video, we shifted our attention to a property or a certain behavior of a process. That is, a process spends its lifetime in two major activities, either doing computation on the CPU, or either performing IO operations. And this behavior of the process is called CPU IO burst cycle. So we discussed the CPU IO burst cycle. That is, you can see from this figure that how a process spends its time by alternating between either performing computation on the CPU or doing IO operations. So all processes behave in this manner, and they can also be classified as CPU bound versus IO bound processes depending on the amount of computation that they do. So understanding this behavior helps the operating system in properly making decisions while time sharing the CPU, right? So this was about the CPU IO burst cycle. And finally, in the previous video, we developed an analogy where basically we brought together all of the ideas that are related to time sharing and tried to develop an analogy between the activities that the operating system does while time sharing the CPU among the different programs. How we looked at how it is very similar to what a music DJ does when he is creating a music mashup. That is, he's switching between different songs, and how this switching of different songs on the music player is very similar to what the operating system does while time sharing the CPU. Basically, this whole analogy I built up so that when you think about the concepts of time sharing, you can kind of correlate this with the real life practical examples, right? So this was just to give you or give you a better understanding so that you can whenever you think about these concepts, you can think about them in a more practical way. So this was the analogy, right? So these are all the ideas that we talked about in this video, right? In this topic. So now we are done with this topic, that is process introduction. We now have a good understanding of what is a process, and we have talked about several aspects that are related to a process. So now that we have understood what is a process, we can start the next topic, that is process address space. So from the next video onwards, we will discuss what is the process address space. Basically, it is the memory of the process. Understanding how the memory of the process looks like is very important to understand the overall execution. So we'll see in this next topic how the code and data is organized into different sections into the process memory, and how the process address space is actually laid out. So guys, this was it for this video. In this video, we summarized all that we learned in this topic. So this topic is now over. From next video, we'll start a new topic, that is process address space. So guys, this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.